All right, let's talk about something we do dozens, maybe hundreds of times a day without even thinking about it. Visiting a website. It feels so simple, right? It feels instant. But what's really going on behind the scenes is this lightning fast, unbelievably complex journey. So let's peel back that curtain. I mean, really, have you ever stopped to think about it? In that tiny sliver of time, that fraction of a second between your finger hitting the key and a web page just appearing on your screen, a whole whirlwind of activity kicks off across the entire global internet. We're going to follow that journey every single step of the way. So, to make this real, we're going to follow one single request. Imagine we're typing https://www.google.com into our browser. We are going to track that command from our keyboard all the way to Google's massive data centers and all the way back again. So first things first, our journey kicks off right there, inside your web browser. Before it can go out and grab anything from the internet, it has to figure out what you actually asked it to do. It has to become a bit of a code breaker. Your browser takes that URL and just dissects it into these critical puzzle pieces. It sees HTTPS and immediately knows, okay, this needs to be a secure, private conversation. It spots www.google.com and knows that's our destination. It doesn't see a specific port number, so it just defaults to 443, which is the standard for secure traffic. And that little slash at the end, that just means get me the main top-level page. Just like that, the command is understood. Now, before it goes on this huge trip across the internet, your browser does something really smart. It's kind of lazy, but in a good way. It asks itself a very simple question. Can I take a shortcut here? Have I already done all this work recently? And that shortcut is called the cache. The browser quickly checks its own memory, the RAM, and then its hard drive for a saved copy of Google's homepage from a previous visit. If it finds a fresh copy, boom, the page loads almost instantly and our journey is over before it even started. But for the sake of our story, let's say the cache is empty. Now the real journey begins. Okay, so no shortcut for us today. The browser knows the name of where it wants to go, google.com. But here's the thing, the internet doesn't really run on names. It runs on numbers. So our next job is to find the right number in the internet's gigantic address book. And this right here is the fundamental problem we need to solve. We humans, we love easy-to-remember names like google.com. Computers? They couldn't care less. They need precise numerical IP addresses to find each other on the network. The system that does this translation for us is called the DNS, the Domain Name System. Finding that IP address isn't just a random shot in the dark. It's this brilliantly efficient hunt. The browser doesn't just shout out to the whole internet. No, it starts local. First, it checks its own memory again. Nothing? Okay, it asks your operating system, Windows, Mac OS, whatever you're using. Still no luck? It moves outward, asking your router. Then it asks your internet service provider. It's only if none of those nearby sources have the answer that it finally goes all the way up the chain to the core root servers of the internet. It's this logical, relentless search that finds the answer in the fastest way possible. Awesome. We've got the IP address, we have our destination locked in, but we can't just start shouting our request across the open internet. Remember, we used HTTPS. That S stands for secure, and it means we first need to build a private encrypted tunnel between our computer and Google's server. The very first step is to make sure we have a stable, reliable connection. This is called the TCP three-way handshake, and you can honestly think of it as a very polite digital instruction. Our browser sends a little packet, a SYN, that basically says, "Hello, you there?" The server gets it and replies with a SYN-ACK, which means, "Yep, I'm here, and I hear you loud and clear." Our browser then sends one final ACK back, saying, "Great," and just like that, the connection is open and stable. Now that we have a stable line, we need to make it private. That's where TLS, or Transport Layer Security, comes in. You know that little padlock icon you see in your browser's address bar that tells you a site is secure? This is the technology that makes it happen. It's the magic that keeps your information safe. So in another super fast handshake, the browser and the server get a few critical things done. The browser checks the server's ID card, its SSL certificate, to make sure it's really talking to Google. Then they agree on the best way to scramble their conversation, negotiating an encryption method. Finally, they create brand new secret keys that only they will use for this one session. With that done, our secure, private tunnel is officially built. All right, let's recap. We've got the address, we've got a solid, reliable connection, and we've wrapped that connection in a secure, private tunnel. Now, finally, our browser can actually ask for the web page. And this is what that ask actually looks like under the hood. It's a simple text command called an HTTP request. It's super clear. It says get, which is the action. It wants slash, the main homepage. And it also identifies who it's talking to, the host, www.google.com. This nice, clean command is then shot through our secure tunnel. Google's server gets that message, and boom, it sends a reply. The very first thing it says is a status code. 200 OK is exactly what we want to hear. It means success, got it, here's what you asked for. And right after that, the server starts sending the good stuff, the raw HTML code that makes up the Google homepage. So this bundle of raw HTML code has made it all the way back to our browser. But a text file isn't a web page, right? This is where the final and maybe the most incredible part of the journey begins. The browser now has to put on its hard hat and act as both an architect and an artist to turn all that code into something we can actually see and interact with. This whole process is called the rendering pipeline, and it's like a super fast assembly line for building a website. First, it reads the HTML to build the basic structure, the skeleton of the page. As it's doing that, it sees links to style files, the CSS, so it goes and fetches those to figure out all the colors, fonts, and layouts. It combines the structure and the style into a render tree. Then it does the math to calculate the exact size and position of every single box and button. And finally, it paints the pixels onto your screen. But get this, that was just for the main document. That initial HTML file is usually just a blueprint. It's full of references to dozens, sometimes hundreds of other files, things like images, fonts, and little bits of code. For every single one of those, the browser has to repeat parts of this journey to go out and grab them too. And there you have it. Let's just take a second and look at that whole journey all at once. You press enter. The browser checks for a shortcut, finds the IP address, establishes a connection, secures it, asks for the page, gets the data back, and then builds the visual page right in front of your eyes. It is an incredible relay race that happens across the entire globe. And the craziest part, this entire deeply complex dance, it all happens most of the time in less time than it takes you to blink. It is an absolute testament to decades of brilliant engineering, which really makes you wonder, right? As we demand web experiences that are even faster, even more secure, even more interactive, how is this invisible, incredible journey going to have to evolve to keep up? Something to chew on. Thanks for tuning in.